Hey everyone, my name is Sarah and I'm going to be helping out with this year's science section. I'm going to try my best to at least show up maybe once a month to help out in person in case if anybody has any questions or such and sort like that. But for now, I'm just going to be making these quick little videos to go over the chemistry section with you. And yeah, I think everybody will maybe find this section a little cool this year. But if you don't, you either love or you hate chemistry. A little bit about me, I love chemistry, so completely understand if you hate it. Hopefully by the end of this resource guide, you can at least learn to love a little bit of some parts, because it will go by a lot more smoothly if you at least like what you're studying. So this year's chemistry section or science section is definitely a little bit of a challenge. It's not the chemistry that you're used to. It goes a little bit beyond that. I think if you've taken AP Chem, you may find a lot of this stuff familiar, and that's really good. But I would definitely say if you're majoring in anything STEM and you have to study beyond Chem 1, that this section is of some value to you. So today we're going to kind of just be going over a review of chemistry so that when we jump in and we start using certain terminology, you'll at least know what it is. So first things first, we're going to go into what chemistry is. Yes, of course I use Father Google to give you a better definition. So chemistry is a scientific study of the properties and behavior of matter. And that's a really important thing. It's the behavior and the properties. So the properties include the protons, neutrons, electrons, and then how they behave. That's literally the definition. Behavior, we're basically talking about the reactions of matter. So if you've taken physics, this may be looking like a similar definition, but what physics deals with is the physical properties of matter. That means how fast they're moving, so things like acceleration, velocity, speed. They deal with things like that. Rather, with chemistry, you're dealing with a bit of a closer look onto an atom and how it's behaving in terms of with another atom and then what it produces. While physics just deals with, what's happening, what does it look like it's doing, is kind of a way to visually describe it. The next thing I kind of want to talk about is the different types of chemistries. Luckily on here, you're only going to be talking about chemistry and then nuclear chemistry. But I think that's a really good way to describe what chemistry is as well. So nuclear chemistry it's in its name, nuclear. It deals with reactions in the nucleus. That means the reaction happens in the nucleus where your protons and your neutrons are at. That's where the reaction happens. And then there's two different reaction types. There's fission and then there's fusion. So fission, an example of it, is what happens on the sun. Basically what the sun does is it takes hydrogen and it turns it into helium. Fusion is what happens when the atomic bomb. So those are the two best examples that we can talk about. But the very important thing that you need to get out of this is that the reaction happens in the nucleus. Meanwhile, all of our other reactions happen on the outermost shell of the compound or the atom or the element. So the outermost shell has these electrons. They're called valence electrons. And this outermost shell also has the highest amount of energy. And that's why it's reactive, because it has this high amount of energy. It's going to react with other elements or other compounds. So this is the basic gist you're going to get of chemistry. Most of what this packet talks about is reactions that happen with electrons, not reactions that happen in the nucleus. It's pretty short category, and if anything, we will focus on it at the end. the next thing that is very, very important in chemistry is your beautiful periodic table of elements. So if you do not know what it is, here it is. It's on page 91 of your resource guide. So we're just going to be kind of talking about the different types of elements on the periodic table. So the most important ones you're going to have, first off, let's up and down, like here. So this right here, this is group 1A, and then this is row 1, row 2, row 3. You get the gist, going this way. So group 1A contains your alkali metals. Mind you, hydrogen is not a metal, it is a nonmetal, it is a gas, but it reacts like an alkali metal, so that's why we have it in group 1A. Sometimes you'll see with some periodic tables, hydrogen will flow a little this way just so it can signify that it is a gas, a nonmetal, rather than a metal. So these are your alkali metals. They're highly reactive because they only have one valence electron. Number 2 is your alkali earth metals. They're reactive as well, but they're not as reactive as your alkali earth metals. Okay, then we move on to our groups 3A, 4A, 5A, 6A, 7A, and then 8A. So from these, I would say that the most important ones you kind of just know and memorize just by heart are your carbon, your nitrogen, your oxygen, your fluorine, your chlorine, your bromine, your iodine, your acetylene. God, I can never say it. Tellurium, you don't really need to memorize it. There's not going to be a lot of reactions where you see it. Same thing with antimony. You're not going to really see it. Arsenic, maybe. Germanium, maybe. Silicon, yes. Phosphorus, yes. Boron, yes. Carbon, yes. Nitrogen, yes. Oxygen, yes. Fluorine, yes. All of those, you're probably going to see them, so I would suggest memorizing this little thing right here, its atomic number, so that tells you how many protons and electrons are in there. And then if you want to know how many valence electrons your element has, you look at the group. So if it says group 7A, then it has 7 valence electrons. If it says group 6A, it has 6 valence electrons. 5A, 5 valence electrons. 4A, 4 valence electrons. 3A, 3 valence electrons. These are a little different, and we'll talk about it when when it comes to it. So these little transition metals here, they can have either 1 valence electron, 2 valence electron, 3 valence electron. It just depends on what they're reacting with. So definitely memorize your alkali metals. You do not need to memorize francium and then cassium. I don't think. Barium, yes. Strontium, yes. Calcium, yes. Magnesium, yes. Beryllium, yes. Sodium, definitely. Potassium, definitely. Rubidium, probably. Lithium, yes, definitely. So we talked about our alkali metals and alkali earth metals. Let's talk about our halogens. So our halogens are our most reactive nonmetals. And it's kind of the same concept as why your alkali metals are the most reactive. It's because they have only 1 valence electron on their... They have 7 valence... They have 7 valence electrons on their outermost shell. That means they only need to add 1 more electron to complete that shell, which is the goal of every element and compound. They want to have a complete outermost shell because they want to feel special like the noble gases, which have a complete outermost shell. So that's a really important concept of chemistry. These reactions are happening because either positive and negatives are attracting together, or these common elements are sharing electrons between each other. And that branches on to our next topic. What's the difference between an ionic and covalent bond? So an ionic bond happens between a metal and a nonmetal. So for example, lithium with oxygen, sodium with fluorine, chlorine with potassium. Not to be confused, Hydrogen, like I said, is a nonmetal. So if hydrogen reacts with fluorine, it's going to be considered a covalent bond. So that's what a covalent bond is a reaction that happens between a nonmetal and a nonmetal. And this is a very important concept of covalent bonds. Ignore that. This is a very important concept of covalent bonds. They share electrons between each other. They don't give or take electrons like an ionic compound, like ionic bonding. So that's a really important concept of chemistry. So we're going to move on to the next little part of it. I sent Lacone some questions that hopefully he did ask you guys. If he didn't, that's fine. We're going over them now. Okay. First thing is first. What is the difference between an atom and an ion? So an atom is neutral. An ion is not. If an ion has a plus on the very top of it, so let me that was my cat. Let me write it out for you. So if so let's say we have boron. So if boron has a plus charge on the top, so it's like this, it's going to have a little exponent with a positive on it. The definition of this is that boron is positive, has a positive charge, which means, so what does that mean? Which means that this specific ion of boron has less electrons than it does protons, meaning it has, which means it has a positive charge, and vice versa. Now, if you have boron minus, the minus is at the exponent, that means it has a negative charge. So what does that mean? Well, basically the reverse concept that we just said, which means this specific ion of boron has more electrons than it does protons, which means it has a negative charge. So that's the difference between an ion and an atom. It's very basic. It's a very basic concept. Whether it has a positive or negative charge, or has that little plus or has that little minus, it means it's not neutral anymore, which means it's an ion. And that's the gist you're going to get from it. So what reacts in a chemical reaction? Is it the electrons, the protons, or the neutrons? Which question we went over. A chemical reaction, most of the ones that we're talking about now, the reaction happens where? The reaction happens in the outermost shell of the element or the compound. And what's reacting? Only the electrons are reacting. Okay? Our third question says, what is the difference between nuclear chemistry and chemistry? Which is something that we talked about as well. The difference between nuclear chemistry, I spelled that wrong, and chemistry is that one reaction happens in the nucleus, while the other reaction happens in the electron cloud, which is just another way of saying where the electrons are located, which is the electron cloud. with the valence electrons, which these electrons are on the outermost shell of your outermost shell. Okay, the fourth question are what are valence electrons and where are they located? So valence electrons are the electrons that do the reacting, and they are located on the outermost shell. We kind of already went through these questions, but this is just kind of a summary for the end of this little lesson. And number 5, what is the difference between a bond and an intermolecular force? What is an intermolecular force and why are they important? So here's where we kind of get to it. A bond results from a reaction and is why the elements and compounds, elements or compounds bind together to create something new. Now, an intermolecular force is a little different, and it kind of branches on to one of your first topics in the book. So, on section number where is it? I cannot find it. On the very next section, chemical bonding and intermolecular forces, we get into what an intermolecular force is and what these binding forces are called. So I know I used the word binded here, which is not, I think a better way of saying it is bonded then. Yeah, bonded together to create something new. So this is, it's short, but it does play into a lot of this other stuff, which is why I think it's pretty important. So we're going to kind of go over it as our first section. So I want you to read over, right now, we're going to do a little pause. I want you to read over pages 15 through 19. And then we're going to come back and we're going to answer this question together. Okay, I hope everybody has gotten a chance to look over it. So I'm going to kind of simplify it down for what they're talking about. So you saw things like hydrogen bonds on there, ionic bonds, metallic bonds, all of that great stuff. And I want you to just know that they're just ionic bonds and covalent bonds do have groups. Same thing that chemistry is the broad category. Then you can go into biochemistry. Then you can go into biomedical chemistry. Same thing, you can go into nuclear chemistry, or then you can go into nuclear physical chemistry. There's just like a lot of things that just start branching off. But our question is, what is an intermolecular force? So an intermolecular force describes why the reaction happens, and that is really important. So sometimes I'll abbreviate intermolecular forces by saying IM, or IMF, and that's just me saying intermolecular forces. So intermolecular forces are why the reaction happens. So with an element, and I'm just going to pull up a little image so if you're a visual learner, you can at least see it a little better. Oh, let me actually do polarity. Actually, I think there may be an image of this on here. page 15. Let me see. They don't show it really well. Let me just pull up something. Polarity. Okay, so this is a little image right here. If you want to know what it is, it's water. That's your little oxygen. That's your hydrogen. That's your hydrogen. And you know this because there's only one bond between each of them. That little line right there is a bond. So that means it's sharing an electron between each of them. So this is water. This is basically your one of the best ways to showcase polarity. So on a compound and even on your elements, even if they're not an ion, they have a slightly positive or slightly negative charge. Oxygen, since it wants to take electrons, it wants to take 2 electrons specifically to complete its outermost shell, it's considered slightly negative. It's slightly negative. Someone emailed me. And then hydrogen, since it's kind of willing to give, it's the one that's more willing to give, it has a slightly positive charge. So the important thing with this right here is that we know that. It's the same thing with a compound. Some compounds, just based on how many of one element is reacting with the other element, the compound may have a slightly more positive or negative charge. So that's going to be a polar covalent bond because it does have polarity. It still has a charge to it. And this is a very small charge. So that small charge is what your IM forces are. It's basically describing that since we still have this concept that a positive attracts a negative, we have those moments, what we call them, where your element is being attracted to each other until it comes so close that it ends up reacting. And that's why we have these reactions. IM forces describe why our elements are being attracted to each other. And the whole reason is because some are slightly positive, some are slightly negative. And some of these charges are so positive or have such a strong polarity that they have stronger IM forces. They're so attracted to each other that they have such a strong bond and they have such a strong reaction to each other. And that's what these IM forces are. So this is a really important concept to understand. And if you didn't get it from what I was talking about, I would definitely search up the organic chemistry tutor and search up what these charges are. Memorize what these ion dipole, these dipole. You don't really need to do ion induced dipole induced. I would definitely say dispersion forces. All of those, I would kind of go over and memorize them, familiarize yourself with them. There is a list of charges that I'll give, IM forces that I'll give to you. So these are the ones that I really want you to focus on, and they already kind of have them on here. We're going to start off with dispersion forces. So dispersion are your weakest of your intermolecular forces, and all elements that react with one another or compounds have them. Then we go into an instantaneous dipole reaction. This is slightly stronger than your dispersion force. Somebody is calling me. This is slightly stronger than your dispersion forces. Then you have a dipole force. And I want to go back a little bit to instantaneous dipole. So instantaneous dipole really depends on the polarity of a element or compound, and that's a really big concept when it comes to instantaneous dipoles. The intermolecular force, or the attractiveness to each other, only happens because of the polarity of said element or said compound. Then you have dipole-dipole forces, which are slightly stronger than instantaneous dipole, or stronger than instantaneous dipole. And then you have your hydrogen bonding. This is a type of intermolecular force, and this is what is considered your strongest intermolecular force. I do believe there's another one, but I can't remember it off the top of my head. And it's so strong because it just has, hydrogen has such a strong polarity, and meaning it is it presents very slightly positive. It's a little bit, it just presents pretty positive, and that's the way we're going to say it, because of that is why these elements these elements or compounds are so attracted to each other, is because of that hydrogen. Since it has such a high slightly positive force, it's going to be, or positive polarity, it's going to be attracting all of these more negative elements, slightly negative elements to it, like just really well, because positive attracts negative, or opposites attracts. Excuse me. So that's basically gonna be our review for today. I know it was a long little video, but it was 30 minutes. That's less than class time. I think this is a pretty cool topic this year. I do hope that everybody can learn something from it. I want you all to know now that you have finished with one of the sections. What's it called? Section 1, this one right here, kind of covers what we talked about. We'll go over John Dalton's law of partial pressures another time, but at least now we'll also go over isotopes, and then we'll go over all of these things. This can be condensed pretty fast, and it's just a lot of review from what you already know. So I hope you liked this little video. Like I said, if you have any more questions, go onto the OChem tutor, or you can email me, and Lacone will send you my email. I'll try and get back to you as soon as possible. But I do have classes every single day of the week, and I am doing my own work. So if I can't get back to you as soon as possible, just know that I have your question in mind, and I'll try and get back to you as soon as I can. Oh my God. Another thing, you will be starting on your math section, I hopefully soon. When you do, I do believe it's mostly algebra this year. I'm more than happy to help with the math section too. If you have any questions about that, just let me know and email me like I said. Anyway, I hope everybody has a good day and that you actually watched this video. Yeah, have a good day, guys. I'll see you whenever I can.